Classification of matter. The universe is made up of about 114 elements.
Yeah. 92 of those are naturally occurring. Yeah.
Does that mean the rest of them are all synthetically made?
Yeah, I think so.
Synthetically.
Man-made?
Man-made. Matter comes in a variety of flavors.
Like carbon-flavored, nitrogen-flavored.
My favorite, gold.
Gold-flavored?
Yep.
Gold-flavored is nice. And basically, one of the things that we're looking for here is we want to come up with some way of organizing our understanding of these 114 elements, because it turns out you can arrange these 114 elements by themselves, or like we discussed before, you can turn them into compounds. So 114, being able to make compounds with 114 other elements, that's a lot of different ways to organize.
Every compound on the face of the earth, everything I eat, drink, shampoo, soap, toothpaste, everything is made up of those elements, some of those elements in some way, shape, or form.
Yep.
There's only 92 of them that are naturally occurring. That's amazing, because there's an awful lot of compounds in the world.
Yeah, there's sugar, there's toothpaste, there's mouthwash, and
medicines,
everything's
foods,
different.
drink, you name it.
They're just reorganized and
Wow.
deorganized in different ways. So one of the ways of organization is to talk about pure substances. A pure substance is one that's made up of similar particles, similar pieces. Those could be elements, or they could be compounds that are going to have similar properties. If it's elements, it's only going to contain one kind of atom. Some examples: gold, helium, neon. And we start getting into some funky stuff here. Oxygen, it turns out that 3 oxygen atoms can come together and forms a molecule called ozone. If I had a whole sample of ozone of 3 oxygen atoms together, it's still a pure substance because it's all the same elements. It's oxygen and oxygen and oxygen. Same thing if I'm talking about just oxygen gas. Pure oxygen gas is O2. Sometimes we refer to this as elemental oxygen.
And there's one of those diatomics again.
Yeah, it's diatomic. Let's see, what are the diatomics?
I call it the hell no halogens. Hydrogen gas, nitrogen gas, oxygen gas. Then you got the halides, fluorine, chlorine, and they're all gases. And then you got bromine, which is a liquid. And then you got iodine, which is actually a solid.
And these are all diatomics.
These are all called diatomics because they are elemental, and there's 2 atoms, 2 like atoms bonded together.
And let's see, there's 1, 2, 3, 4, 5, 6. There's 7 of these diatomics, so we got to memorize 7 of them.
Yep.
Do you think the periodic table can help us out?
Yeah, because if you look at them on the periodic table, it forms kind of a 7. If you start at the hydrogen on the left and you draw a straight line, you pass through or just above nitrogen, oxygen, and then draw the line down, it looks like a 7.
Yeah,
Otherwise, I like to say hell no halogens because I can swear for the only time in class.
Hell no halogens. There you go. All right. All right. Compounds, different from elements because they have more than one kind of atom. Sometimes we call compounds molecules. You can see here we've got some examples. Carbon dioxide, we've got carbon and oxygen atoms. Copper sulfates, we got copper, sulfur, and oxygen. Sugar, this is nice, that's sweet stuff.
Yeah.
We've got 6 carbons, 12 hydrogens, and 6 oxygens. Water, obviously a compound, hydrogen and oxygen. Aspirin, we got a lot of different compounds. I think you were just alluding to
tons,
that.
Yeah, there's tons and tons. Mixtures. Mixtures can be made up of more than one pure substance. So a mixture is literally you have oxygen and nitrogen in the same container. That is a mixture of 2 pure substances. So it is a mixture. Mixtures can be separated via physical properties.
Okay, so sorry.
Right, there are 2 types of mixtures, heterogeneous and homogeneous. Heterogeneous means different. That means that when you actually look at the mixture, you can see the different parts to it. You can see that it is not, it's not smooth throughout.
So maybe like a bowl of M&Ms?
Bowl of M&Ms, my particular favorite. Granola is a good example where you can see the parts, you can see the different parts.
Especially like nutty cranberry maple granola.
Nutty cranberry maple granola.
All right. Pulpy orange juice, Rocky Road ice cream,
Yep.
M&Ms.
M&Ms, yep. A homogeneous mixture is that it appears consistent throughout the entire container. If you were to take a piece of that sample from each part of the container, it's going to have the exact same consistency. It's going to be exactly the same. 14 karat gold, iced tea, the room you're sitting in, the air in the room you're sitting in. If you were to take a sample of the air from the back of the room and the front of the room, it will be identical.
Mm-hmm. So we mentioned that mixtures can be separated through physical means. This is one method of separating. It's called distillation. You're just doing phase changes, which is a physical process. You heat up a substance, get it to evaporate, and then get it to cool down. What we can do here is we can separate two substances that have different boiling points. Maybe like we've got alcohol and water mixed together here. Alcohol boils at a much lower temperature than water, so it'll all boil off first. It'll come down this tube, it'll get cooled by the cold water that's in this condenser part, and it'll turn back into a liquid and fall into this flask here. So this flask should be pure alcohol.
Right, and the other flask will be the water.
That'll have whatever's left over the water. Yeah, okay.
Distillation is used a lot in organic chemistry. Filtration, this is a nice simple way of separating a really chunky mixture. Filtration is usually used to separate a solid from a liquid. The liquid that's in the Erlenmeyer is called the filtrate.
And I just like to point this out. This is a heterogeneous mixture up here, whereas the filtrate should be homogeneous. Just to use the words that we already set up there.
Chromatography is usually used in the ink business. It separates substances on the basis of differences in solubility in a solvent. Notice that on the far right, the blue ink molecule has a different solubility than the violet one. So it dissolved faster in the solvent than the violet one.
Okay. And here's just a brief graphic organizer to show you what's going on here with classification of matter. All matter can be classified as matter. Some of it is a mixture, some of it is a pure substance. If it's a pure substance, then you can break it down into either elements or compounds. If it's a mixture, you could break it down into heterogeneous mixtures or homogeneous mixtures. Question of where do physical changes wind up being incorporated in this chart? Well, physical changes are between pure substances and mixtures. I could take two pure substances and just mix them together, and I've got a mixture suddenly.
Yep.
Right? Okay.
Or you have a mixture and you can separate it into two pure substances by chromatography, distillation, or filtration.
This is true. Okay. If you can do one forwards, you can go backwards. Chemical changes come in place between elements and compounds here. If I've got two types of elements, there are probably ways that I could take two types of elements and make them compounds. Probably any two elements I want, nearly on the periodic table, nearly any two elements. And I could also do the same thing. I could take compounds and I could break them down into elements.
Now, when you're categorizing these things, please remember there's no crossover. There's no such thing as a heterogeneous element. It's a heterogeneous mixture or it's an element. There's no crossover between the left and the right.
Mm-hmm. Here's a challenge for you. See if you can figure out whether these different types of matter are pure substances or mixtures. If it's a pure substance, tell me whether it's an element or a compound. If it's a mixture, tell me if it's heterogeneous or homogeneous. Press pause, figure it out, and when you press play, you'll see the answers.